Okay, red light seems to indicate that we can go ahead and get started. So I wanted to show you kind of the question of the day first. We had an optional lecture on Wednesday, so some of you may not have seen the one from Monday, so I thought I'd just kind of show you. I thought it was an interesting set of answers to that question. That was the Monday question about fall. I was surprised that these percentages were as high as they are. So anyway, in case you're interested, that was from the question from Monday. And we did have a question of the day from last time. Not quite as many people filled it out. Probably we had because of the optional lecture. But here are the answers to the Wednesday question. I think I'm in a little trouble because I'm definitely in the yes camp that cold pizza's fine. Anyway, so that was the result of the Wednesday question of the day. I wanted to mention, so you remember with homework 2 and with homework 3, there was the ability to do a little creative, ASCII art and for homework 2 and a little graphics doodle for homework 3. I have collected together the ASCII art things that everyone in the class did and the graphics that everybody in the class did, and made a gallery out of it so you can click on those. It's really cool, very interesting. I mean, some of you just kind of did the basic, which was fine, but there are a fair number of people who put a lot of effort into those two creative aspects. So anyway, check it out if you're interested. No homework due next week, so this is kind of the week when we have a bit of a pause. You can catch your breath, and I've suggested that you reflect on things, try to, if there's anything that's still a little fuzzy, try to fill in the background a little bit. And I've said that I don't think that it's a crazy idea that you would actually try taking a midterm. So I've tried to make that very doable for you. So there's a sample midterm here with a key and the midterm cheat sheet so that you can see that you would make that available to yourself during the exam so that you'd be able to have the same thing that students have. And I've made a second sample midterm available to you with a key. So that's kind of an extra resource, an extra opportunity to do that. And as if 2 wasn't enough, there's a third one. So if you go to the Sections tab, we had lots of stuff on the Section tab for yesterday because we were giving the TAs flexibility to do different things in their section depending upon what they thought their students would enjoy. But one of the things that was there was a third sample midterm. So this set of practice it problems represents an actual midterm that has been given relatively recently. So that would be another way to do it if you didn't do that in your section, is that you could go through these practice it problems as a way of reviewing. So anyway, I think it's a good idea to do that. It's up to you to decide. Today we're starting material from chapter 6. So, and I'll finish it on Monday and pass out the new homework assignment on Monday. Due a week from Tuesday. So don't worry, don't panic. Nothing is due next week. So this assignment, chapter 6, is moving into an area that I think is an important one for intro computer science. So if you went back to the 1980s, if you looked at what was going on in intro computer science, it would have been considered a very basic thing that we do file processing assignments. But Java is not a programming language that was designed to handle files well. We were using Pascal as a teaching language, and then we used C++ for a while. C++ grew up in the 80s when files were the thing. Almost all of the data you cared about was stored on files somewhere. So actually C++ is a programming language that has great file processing, really easy to use features. Java's really annoying in terms of the file processing features. So a lot of instructors just stopped talking about file processing. I think that's a mistake. I think that's sad because there's a lot of interesting programming assignments you can give where there's say a data file to read, an interesting data file. I also think that as a practical skill, it's really useful for you to know how to process an input file. Many of you might be scientists, engineers, even people in the humanities. You may find yourself wanting to go through and process a file of data, or look at a Shakespearean play and count vocabulary, for example. So there's a lot of applications for being able to process files. So I think it's an important thing to teach you about before you leave the course. And so that's chapter 6, is to deal with file processing. So let me start here. I'm showing you here something called numbers.txt. So let me tell you what I did is that I just typed some text into a text editor, and I saved it as numbers.txt. So I just created a file and saved it with that name, numbers.txt. I'm going to spend a little bit of time in interactions first, and by now you've gotten used to the idea that there are imports involved. So there's going to be an import on java.util.star that's going to allow me to do scanners. There's another kind of an import that we're going to start doing for, starting with this chapter 6 material, which is java.io.star. And I usually ask, what does IO stand for? And somebody says input, output. It's a common bit of terminology among programmers. So there are some things that are in that IO package that we're going to want to be able to use. So your file processing programs are going to include these two imports, java.util and java.io. I want to talk a little bit about a class that's known as file. This is the beginning of chapter 6 as we talk about file objects. It turns out we're not going to do a lot with file objects, or this particular Java class that's known as file, but it's worth spending a few minutes talking a little bit about a file object. So I'm going to say I want a file F, which is a new file object connected to numbers.txt. So in parentheses, I put the name of this file here that I had created, numbers.txt. It's unfortunate that it uses the name, that this is called file, because it kind of implies that it is the file, that F somehow is the file. I mean, a better name would have been file handle or file connector or something like that. It's an object in your Java program that is trying to connect to a file, that gives you access to an external file. With all of these things, I've mentioned to you that if you go to the links here, and then under links you go to Java API documentation, you can look things up. I did that before class, so I kind of opened up the link for the class known as file, an abstract representation of file and directory path names, so you can read kind of the internal description of it here. And then there's a whole long list of methods, things that you can do with a file object. There's a similar table in the slides and in the beginning of chapter 6. Let me show you just a few things you can do with a file object. One that seems a little odd is you can ask it whether it exists. Well, why do you do that? So I gave it a name here. I said, numbers.txt. Well, you can make a file object where there's no such file on the computer. It may be that you spelled the name wrong, or there just doesn't happen to be a file, or it's in a different place than you thought it was. So there's a lot of reasons why the file might not be there. So this is again an indication that it isn't actually the file. It's something that's trying to connect to a file. So by saying f.exists, I'm saying, is there really such a thing? Did you find a numbers.txt? And it says, yes, I did find a numbers.txt. Well, then I could say things like, what's the length of that file? And it tells me it's 53 long. That's a character count, how many characters are in the file. So it's letting me know that it's 53 characters long. I could ask it for things like, what was the name of that file? And it kind of reminds me that it's numbers.txt. There's something that's going on here that I wanted to mention briefly. I'm not going to spend a lot of time on it, but it's worth, again, kind of mentioning that there's a distinction between a relative path versus an absolute path. So this is an issue that you deal with when you're doing file processing, is how do you tell the computer, how do you specify where the file is? So here, I just used a simple name, numbers.txt. That's what we would call a relative path name. And that's what you get when you say f.getName. That's the simple name for a file. And so for a relative path, the idea is that there's something that's considered the current directory, the working directory. Where are you located right now? And so it looks in that current directory to find the file that you've specified. For our Java programs, the current directory is going to be considered whatever directory has the program that you're writing. So what we're going to do to make this simple is that we're going to put our data files in the same directory as the programs we're writing. And by doing that, we'll be able to use relative names, simple names, to specify it, and Java will be able to find it. But you can ask, what is the get absolute path? That's kind of showing me the more detailed path. So this is on a Macintosh. That there is at the highest level of the file structure, there's something called users. Within that, there's something called regis. Within that, there's something called 142. And within that directory, there's a numbers.txt. So this is an absolute path from what we call the root of the file system. So you can specify it that way as well. On a Windows machine, this looks a little bit different. You tend to have things like C:, the hard drive on your computer, for example. In any event, if you're interested, you can read a little more about absolute path. It's not something that you're going to need to worry about for this class, because we'll just use the relative path names. Okay, well, that's some various things you can do with a file object. It turns out that that's not what we're going to use it for. We're going to use it in conjunction with a scanner. So what we're going to want to do is to use a scanner, and we're going to want to be reading from files. I wanted to say a little bit more about this. The model that's used, or kind of the analogy or mindset they want you to be in, for file processing, is a plumbing model. Is how they want you to think of it. Think of it as pipes with things flowing through pipes, and you can connect this pipe to that pipe, and you can redirect it to that pipe, and you can do various things along the way. Any of you who watched the optional lecture on Wednesday know that this advanced material, the functional programming material, also uses a plumbing model. So they kind of like that idea of thinking of things in terms of pipes and things flowing through pipes. And so this may seem like a strange idea, but I'm going to say that a scanner is like a faucet, if we think about how plumbing works. A scanner is like a faucet. Just for the fun of it, I went to Home Depot earlier today, and I typed in faucet for the search. And it's showing me pictures of various kinds of faucets. I can ask for all the bathroom sink faucets, for example. Here's a picture. Here's some specific ones here. So what if I went to Home Depot and I came across this faucet right here, and I went up to it, be sitting on a shelf or something like that, and I go up to that faucet and I turn the handles? What's going to happen? Is water going to come out of the faucet? I mean, that's what we expect to use a faucet for, is to be able to get water, for example. And you know the answer to this. It's a silly kind of question, right? If you just see it sitting on the shelf and you turn the knobs, it does nothing. Because a faucet is not something that produces water. It's not a source of water. A faucet is something that controls the flow of water. So you could kind of imagine, go to your kitchen sink, for example, and there's a faucet there. What if you took away the faucet? Well, you've got some pipe that's kind of spewing water at you. And so we put the faucet there so that it can control that flow. We can get, a limited amount of water at a time. We use the faucet as a way to control that. Well, that's what a scanner is like. A scanner is an object that we attach to a source of input. So it isn't itself a source of input. We attach it to a source of input, and it allows us to control that source of input. So I've mentioned that system.in is not a very convenient thing, that the way they design Java, system.out works really nicely. It's very easy to work with. System.in is not easy to work with. System.in is like that pipe that has water spewing at you, so it's not a very convenient thing to work with. So that's why we've done things like this. Scanner console is a new scanner. And in the parentheses, we've put the system.in, and that's the way to kind of create the scanner that is connected to. Its source of input is system.in, which is console input. So we've been doing that for a while, is making a scanner that's connected to the console by saying that our source of input is system.in. If you think about something like a faucet, I mean, what would be different sources of water for a faucet? Usually I ask the class, and I have people, people give me interesting answers. If you live in a place like Seattle, there's usually city water, flowing there to different areas. And so usually you can just connect your house to the city water, and that's your source of water. That's where it comes from. Other people, even if city water is available, or if it isn't available, often will have well water. So they'll have a well that they tap into as a way of getting access to water. If you said, what's going on, I don't know if you people are probably not flying on airplanes that much right now, but when you did fly on airplanes, and you will fly on airplanes in the future, you go into their bathroom there, and there's a tiny little sink with a tiny little faucet, with the handles that are there. Where's that water coming from? Is it city water? Is it well water? Well, it's not either of those things. There's some kind of a tank, of water that's somewhere on the plane. So there could be lots of different sources, and a single faucet could be used, to connect to lots of sources. Scanners like that. So system.in was one of our sources. But now what I'm going to do is I'm going to make a scanner that I'm going to call input, which is a new scanner. And what I'm going to use as its source of input is the file, is that file object that's giving me the connection to numbers.txt. So I'm telling this scanner, I want you to look to numbers.txt as the place to get your input. So I'm going to go ahead and hit enter here. And it's set up something called input, which is tied to this file here. So I wanted to show you kind of what we can do with this. We've already seen things you can do with a scanner, so because we've done it with the console scanner. But if we do it here by using this file scanner, so what are the kinds of things we've seen? We've seen that you can do things like a call on next double, so that this file begins with a 308.2, so I could call input.nextDouble, and if that works, if the connection worked, it should get that from the file. So it should read that information from the file. And there is the 308.2. What comes next in the file? A 14.9, a 7.4, a 2.8. So it's just reading these different tokens from the input file and interpreting them as doubles. One of the terms that we use for this is we talk sometimes about the idea of consuming input. It's like you've eaten input. You could think of it as, something has flowed through the pipe, so it's no longer in the pipe. It's been consumed. The faucet has kind of spewed this thing out. And so, we're now past the 2.8. And so, next up would be a 3.9. We can see that. And then a 4.7. And then there's the negative 15.4. And then there's the 2.8. So we can do a series of calls on next double to read in all of those different values. Now it's at the very end. And so now if we try to read again, and we kind of hit this, hit next double, we get an error. It throws an exception. The exception is no such element exception. So it's letting you know there's nothing more to read in this file. So it just didn't work. One of the questions that comes up for this is, can you go backwards? Can you go back one or two of these tokens, or go back to the beginning? Can you rewind it to the beginning? And the answer is no. Java scanner is kind of simple in that it only goes in a forwards way through the file. You can never back it up. So what you would do if you wanted to start over again is that you would say something like this. Input is a new scanner that's tied to that file. You just recreate it. You recreate a brand new scanner. You're going to see up here that the object number is going to change when I do this. It makes a brand new scanner. Now it's object 605, and it turned it red to let me know that that had changed. So it's going to do that. It's basically allowing me to go back to the beginning only because I've created a brand new scanner that's going to start all the way at the beginning. All right. I didn't mention one thing, so let me do this quickly and then we'll kind of come back because there's another thing I want to show you. What if when I was here I had said input.nextInt? So I want to just kind of remind you. So we're back at the beginning, so it's positioned at the 14.9. And if we tried to read that 14.9 as an int, we get a mismatch exception. Remember, we've seen this error before. So if you're trying to read a double, but it sees an int, we get an input mismatch exception. So two kinds of errors. There was no more data, you were at the end of the file, or you had to mismatch. You tried to read things the wrong way. So you're going to want to pay attention to the kind of exception you're getting, because there are these two things, running out of data versus reading data in the wrong way. So that would have been the problem that's there. Okay, what I'm going to do next is I want to show you, let me go back, let's do this. Let me go back and start it all the way from the beginning again, just so that I have a brand new scanner to show you what things are like when you have a brand new scanner. I'm going to drag this out because JGrasp has an interesting visualization of what's going on with this scanner, showing a sequence of characters here. So let me kind of do this. There's a funny thing that's going on that you see all of these weird \0 characters. They're known as null characters. This is kind of, again, not something that's terribly important to understand, but what you're seeing here is that there's something that Java does called lazy input. You could read about this if you're interested. It's a technical term we use in computing, the idea of lazy evaluation, lazy input in this case, that it basically says, look, why should I bother to read a file? Reading a file takes time. Why should I do that until I need to do it? So we need to do something that kind of forces it to read the file. So I'm going to ask for, does it have a next double? So I'm talking about this more in a minute, the has methods, but as its name kind of implies, it peeks ahead without actually reading the scanner. It peeks ahead to see whether the next token can be interpreted as a double. It can be, so let me go ahead and hit the enter key here, and it says true, this thing can be interpreted as a double. And notice, boom, it read in the whole file. So all of those characters have been read in now. Well, one of the things that's interesting about this is that JGrasp is now drawing pictures of scanners that are just like the pictures that we draw in Chapter 6. I've mentioned that James Cross, who does JGrasp, likes my co-author and me a lot, and he's been doing a lot of things to try to make JGrasp work better for us. And so let me talk about the representation that we have here. So you might think of this file as being a two-dimensional thing. It's on several different lines, and so there's kind of lines and columns and so forth. But that's not how the computer thinks of it. If I just select the file, you can kind of see even here that it's not thinking of it that way because, look, it knows that some of these lines are longer than others. So it doesn't think of it as, kind of an indefinitely long line 1 and indefinitely long line 2. There aren't columns over here. There isn't like a two-dimensional grid. It thinks of it in a one-dimensional way. And you can kind of see that here. So what it's showing for the scanner is that it thinks of it as the characters 308.2 followed by \n. We've mentioned this, I think, at least once, that \n represents a new line character. What happened is I typed in a 308.2 and then I hit the enter key. I hit enter on my computer and that brought me to the beginning of the next line. So that's what that is right there. It's kind of the end of a line, a new line character. And then I typed 3 spaces at the beginning of the next line, 14.9, space 7.4, space 2.8. And then when I got, after the 2.8, what I did when I was right here in my text editor is I was positioned at the end of that line and I hit enter to complete that line and go to the beginning of the next line. I hit enter again, which introduced a blank line, and I hit enter again, which introduced a second blank line. So there are 3 new line characters in a row because I hit enter, enter, enter. So every time you hit enter in the editor, and here it's displaying it as being on different lines, but really you can just think of it as a one-dimensional sequence of characters, some of which are things like these new line characters that indicate a line break. And then there was a 3.9 and a 4.7, a bunch of spaces and a negative 15.4, another new line character, a bunch of leading spaces, 2.8, and a final new line character. And then it's showing us those weird characters afterwards there. It started with a 0, so this is that 53rd character. We had asked how long the file was, so that's the 53 characters that are in this file. Another nice thing about this representation is it shows you a little green arrow here that it calls position. I refer to this as the input cursor in chapter 6. So he didn't quite pick up our terminology for it, but it's that idea, the idea that the scanner keeps track of it's like keeping a finger pointing into the file. Where are we in the sequence of characters as we consume the input, as we process the input and move forward? So you could think of it as that all of these things are in the pipe. All of them are in the pipe kind of waiting to be processed by the scanner. So if I come down here and I say input.nextDouble, let me tell you what happens when nextDouble is executed. It skips any leading white space. Remember, white space is a reference to spaces and tabs and new line characters. It's the things that separate words in a file, so white space characters. It skips any leading white space. Well, here there is no leading white space. And then it consumes as many characters as it can until it finds more white space. So it's going to consume the 308.2 and it's going to be positioned here. So I'm going to hit enter and you'll see that it returns the 308.2. It consumed those characters and now we're positioned at the new line character here. So now I'm going to do input.nextDouble again. So what does it do? It skips leading white space, and here there's a fair amount of leading white space, the new line character and the 3 spaces, and then it's going to consume characters again until it encounters more white space, which is going to be this space right here that's listed as being at index 13. So we read the 14.9 and we're positioned here. It's going to skip that. If we do it another call, it's going to skip that and it's going to consume until it gets to white space on the other side of what we call a token, like a word. So it's going to read in the 7.4 as a token and be positioned here. It's going to skip this space and consume the 2.8 and stay positioned here. So skip the leading space, positioned at the 2.8. And, this is probably obvious in the examples I did already, but let me make a major point of it here just so that you understand what's going on. We just consumed the 2.8, and I'm about to do another call on nextDouble. It's important to understand that these methods like nextDouble, what we call the token-based methods, they're reading a token at a time. They don't care about line breaks. They skip past line breaks and move you to another line. So it's going to read in this token 3.9 even though it's on a line that's several away. It's going to skip all 3 of these new line characters because they're just considered white space, and then it's going to consume the 3.9. So in effect, by executing this little command, it skipped past all of those new line characters here, and now it's in the middle of this line. It's kind of positioned at this character right here. So it skipped forward. We're going to talk about this a lot in Monday's lecture because we don't always want to ignore line breaks. We don't always want to scan past a line into the beginning of a new line. So that's going to be an issue we're going to want to think about. So it's important to understand things like nextInt, nextDouble, and next consume entire tokens, and they just kind of do the next token, the next token, the next token, and they don't care how they appear across lines. They're willing to skip lines. Okay, well, that's what I wanted to do with that example. Let me collapse this back down. I want to go to a file wednesday.java. We can end the interactions pane. And I'm going to come here. And I wanted to just type in, I've already got my imports. I'm going to type in the same thing I did in the interactions pane, because there's an issue I need to talk about. So let me make a file object f, which is a new file tied to numbers.txt, just like I did down there in the interactions pane. And let me make a scanner called input, which is a new scanner that's connected to that file. So let's just do that. It's just trying to recreate what we had done in the interactions pane. So let me hit compile. And it says, unreported exception, file not found exception. And then it says, must be caught or declared to be thrown. So this is an error message we're going to have to learn to deal with when we're doing file processing. And this issue alone is enough to cause some intro CS instructors to say, I just don't even want to deal with files. This is Java showing how ugly things can be. So there's an issue here of what's known as a checked exception. So let me tell you about that. We've seen that you can do things that end up producing an exception. You can make a console scanner, and you could say, I want a next int, and it could be that the user types in a double, not an int. And we've seen you get the mismatch exception, right? So you know that you have programs you can write where exceptions get thrown. So that's just a natural thing in a Java program, is that sometimes there are exceptions that are thrown. But when they designed Java, they decided that some exceptions might be considered so important that we would not want you to just ignore that possibility. We want you to think about the fact that that exception could happen, and those are known as checked exceptions. And it's very weird. If you look at it, I mentioned this a little bit before, but if you look at the Java class libraries, I and O, input and output, you'll find that the things that are involved in output tend to be fairly laid back and simple. They don't tend to worry a lot about errors. But I almost feel like there were two engineers involved. Whoever was doing the input side of things was really nervous and said, well, things could go wrong. There's all sorts of problems that could happen, and we need to get people to think about those potential problems. Well, here the problem it's worried about is file not found exception. So you're assuming that there's a thing called numbers.txt, but what if there wasn't? What if there wasn't a thing called numbers.txt? Then there'd be this horrible exception. So a checked exception has to be handled in some way, and the error message says that you can catch it. So I'm going to talk about that just briefly. There is a construct in Java known as a try-catch, where you can have some lines of code, and you can catch exceptions, and you can have lines of code to execute. If these lines of code produce an exception, then it's caught by this construct, and then these lines of code are executed as a way to recover from it. I don't think this is important enough that I want you to take time to learn how to do try-catch. It's in the book if you're interested, so you can study it yourself. But you're not going to have to worry about try-catch in 143, and it's basically forbidden. We don't let you use try-catch because we want everyone to be using the same constructs. So don't worry about the details of this, unless you're someone who just wants to know everything about Java. But so that would be one way to go, is try-catch. It turns out that, so there's the question of whether these checked exceptions were a good idea. And an interesting thing is that when Microsoft made C#, so that was their version of Java, they decided not to include checked exceptions. And I think it's because by then it was pretty obvious that this was turning out badly. Because what a lot of programmers were doing is doing a try-catch where their error recovery code was blank, was empty. They basically didn't want to have to go to the trouble to actually have error recovery code, so they had an empty catch clause, no recovery code. And that's even worse, because now you're not even warned about the error. So I think there's kind of a sense among programmers that this was a mistake on Java's part. But Java makes us live with its mistakes, because they don't want to change the language over time. So this is something, file not found exception is something that's a checked exception. You've got to deal with it somehow. But notice there's some kind of curious language here. Must be caught or declared to be thrown. So there's this other possibility. And this I find really an annoying aspect of Java, but it's just kind of like the people are complaining about the nanny state making you think about things. So this is Java making you think about this. It turns out that what you can do is you can confess to Java. You can admit how flawed you are. So I can say to Java, I can put a little thing in the header for main that says, throws file not found exception. So basically what I'm saying to Java is, yes, I thought about it. I know that it potentially throws a file not found exception. I'm telling you that that's so. I am a deeply flawed main, not an ordinary main, but a main that has this flaw that it sometimes throws a file not found exception. Please, 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 Java, let me squeak by as long as I'm doing this confession to let you know that I sometimes throw a file not found exception. And it turns out that when we compile that compiles. So that's what we're going to do, is in our file processing programs, we're going to write main so that it looks like that. So you thought there was already a lot of stuff you had to have in main with string bracket bracket args. Now you're also going to include throws file not found exception. So it's again just kind of a pattern to remember. This is the way we're going to be writing main when we're doing file processing programs, is we'll include this throws file not found exception. I wanted to mention another thing, which is I mentioned really all we tend to use this file object for is for constructing the scanner. So most programmers wouldn't actually set up a variable f like this. What they would tend to do is they would say, look, well, f was assigned to be set to this, right? A new file object that's tied to numbers.txt. If that's all that you were going to use f for, then why not just put that where you had f? So I'm going to paste and just put that there instead of putting f there. And then you don't need the variable. Then you don't need to introduce an f, which was what you get when you do new file numbers.txt. You can do the f if you want to. If you kind of prefer to see it as a two-step process, that's fine. But this is the way I'm going to show you examples in the class. And this is fine too, is to kind of do it this way. Okay, normally I'd see if there's questions, and often there are. This is a lecture. It's too bad. There's often a lot of things little things people are interested in details about, but we don't have the opportunity to have you ask questions. So I'm going to just kind of move on here. I'm showing you a complete program here, so I wanted to give you an example of a complete program that uses what we've talked about. So I've got the throws file not found exception in the header for main. I'm setting up the scanner using that without using an F, just kind of setting it up directly. And this is a cumulative sum. It's setting a sum at 0 5 times. It's getting a double from the file and then printing out the number and adding it to our sum and printing the overall sum. So it's reading from numbers.txt, and it's going to do 1, 2, 3, 4, 5 of these numbers. So it's going to process 5 of these numbers. So this is kind of a first example of a complete program that reads 5 numbers from a file, and adds them up. So let me go ahead and compile and run. And the output we get is it's showing those different numbers. Maybe I'll show a little more of the output here. It's showing us those numbers that were in the file, the 308.2, 14.9, 7.4, and so forth. And it's showing us their sum. And you might say, wait, what is that? 1999993. This is what we call a round-off error. Why do you get round-off errors? Well, remember that double doesn't store things exactly. It stores it as approximations. So like if you imagine trying to store a third, a third is 0.333333, but there's infinitely many threes in a third. And if you have a limited number of digits, you just kind of chop it off at some point. You only have a certain number of threes. And if you multiplied that back by 3, you'd have 9999999. You wouldn't get back a 1, you'd be slightly off, a round-off error. And you might say, well, wait a second, where's the repeating decimals here? Why would there be a round-off? Well, remember, the computer stores things in base 2. So these things have repeated digits in base 2. And so this is a common occurrence that we get round-off errors. So don't be surprised if we see things like that. That's one of the reasons we'll often do rounding or something like that, because we know there are these little errors that creep in. Okay, so that was that program. I want to make a change to this program, but before that, I want to go back into interactions to show you one other thing before we get there. And I'm going to want to talk about this file called data.txt. I'm going to use that as an example. So we'll do our import on java.util. We'll do our import on java.io so that we can do scanners and make a file. And I'm going to make a scanner input, which is a new scanner connected to a new file object with data.txt. So this is a different file than I had before. Data.txt, again, just kind of a file that I typed in. And so what I want to do now is I want to talk about something I showed you briefly. Remember that I was trying to get the scanner to wake up to avoid the lazy input, kind of fill in things. Well, so we're going to want to be doing things like input dot next in, next double, and so forth, calling methods like that. But Java gives you the opportunity to look before you leap, to check to make sure whether it's going to be okay before you get there. The slides mention this. So in the slides for today, testing for valid input, it shows you for these token-based methods, you can ask has next int, has next double. You can, before you try to read one of those tokens, you can say, you can ask, does it have a next double? So that's what I'm going to ask for first. So oops, that's not what I want to do. That was a 23. So this is a different file. How about if I ask it if it has a next int? So we don't need to, we can collapse that. So it begins with the token 23, and so I'm saying, can you read that 23 in as an int? And the answer is yes, it can read it in as an int. What do you suppose the answer is going to be when I say, could you read it as a double? Well, you could imagine different answers. You could say, well, 23, what comes at the beginning of this file, it doesn't look like a double. It looks like an int, but the question would be, could you, and we talked about this when we talked about the console version of this, and what I mentioned at the time is that if you imagine that if you had a double variable n and you set it to that, you set it to 23, Java is okay with that. Java says, okay, I can take an int and turn it into a double. So even though it doesn't look like a double, I can convert it to a double. So the answer there is true. And the other kind of reading is has next. Next is the method that you use to read it in string form. So it's kind of, can we read it as a string? And the answer is yes. So this token, the 23, can be read all three ways. It can be read as an int, it can be read as a double, it can be read as a string. How about the next one, 3.14? Well, if we kind of go back up, can it be read as an int? The answer is no, because it's got that decimal point in it. So, it would have been good to have done something like next int to actually read in the 23. So I was confused there. Remember that these things peek ahead without actually consuming the input, without actually reading the input. So I was peeking, but I wasn't actually reading. Now I've actually moved forward. Now it's positioned in between. So now the next token really is a 3.14. So let me ask again, does it have a next int? And the answer is no. That can't be read as a next int. Can it be read as a double? Sure, of course it's a double. Can it be read as a next, a string? And it doesn't kind of look like a string, it looks like a number, but you can read it as a string. So that one is still true. And then we could do, say, something like next double, say to read it as a double, and that read in the 3.14. So now I've consumed it, and kind of, what's the next token? Well, the next token is quote John. I mean, we might think of quotation marks as being something that would make a quoted string or something, but remember, Java is using a very simple idea here of just white space. And so if I ask it the same questions, does it have a next int? No, I can't read that as an int. Can I read it as a double? No. But can I read it as a next? Somewhere I've got it has next. Yes. You can always read the token as a next. So I could say, give me the next token, which is quote John. Give me the next one, Smith quote. Give me the next one. Merry-go-round, it has no spaces in the middle of it, so it gives me the whole thing. What comes next? When you tokenize, again, you're using white space kind of to figure it out. The next token it would find is a // and then it would find a this is a comment, and then it's run out. So now if we try running again, I get a no such element exception. Okay, well, let me come back to the echo program, and I want to make a change here. So I want to change this to a program that reads in all of the numbers that it finds in numbers.txt. Here it just did it exactly 5 times. Well, so, numbers.txt had more than 5 of these doubles. So this is a very basic pattern. We're going to see this a lot. We'll do a lot more practice on Monday, but you're going to see this pattern a lot, that you tend to do a while loop because we don't know how many of these things there are. And we basically say, while, what we're about to do is to read in a double. And so before we do that, we say, while input has next double. So while, we peek ahead and see if there is a double to be consumed. And if so, we consume it and proceed. So that would be the kind of the more normal way to write a method like this. Yes, we will end our interactions. And I'll go ahead and compile then and run this version. And now it's reading in more numbers than it read before. It's reading in, boom, it started with a 308.2 all the way through the 2.8. It read all of these in there, so all of that. Okay, well, let's think a little bit about what we would do with a file like this. So what if we were given, this is called numbers2.txt. So I want us to think about how we would change the echoes program so that if it was reading from numbers2, now in numbers2, it's going to find a 308.2, and then the next token it's going to encounter is a hello. So let me, and that's not something that can be read as a double. So if I compile and run this version of it, it only reads in 308.2. It doesn't read anything more, because that was the only number that it found. Well, what if we wanted it to ignore things like hello or bad or stuff? What if we wanted it to ignore things like that? How could we do that? Well, so we could do something in here where we said something like, if the input has a next double, so if there is a number to read here, then how about if we do these 3 things here? And otherwise, that would mean that there isn't a number to read. So that would mean it's something like the hello. So we could read, say, string bad is input.next, and we could say something like system.out.println bad token bad, so that we kind of let them know that they had typed in something that wasn't a number. So this is the kind of strategy we can use as a way of being able to process numbers when it's numbers, and otherwise we read them as strings. We still read them in, and we'll kind of tell the person that they had a bad token. So we can do it with an if-else. Some of you may realize this isn't quite going to work. If I compile and run it, what you see is I still get only one number. Well, so the first time through, it went into this branch and it processed the number, and it came back around, but it was then positioned in front of this token hello, and I've written code that'll process that token hello, but my while loop test is still testing when I have a next double. So it turns out I can't use a while loop test that's that strict. What I want to test for is has next, because I just want to know if there's another token, not whether that token is a number. So I needed to have a more relaxed test in order to make that work. And when I compile and run this version of it, you're going to see now that it shows me number and then a bad token and another number and more bad tokens and more numbers, more bad tokens, and so forth. So it processed the entire file and it kind of alternated between the two. So I'm going to put up on the calendar for today the simpler version of the echo program that kind of always read in numbers, and then this one that does the more sophisticated one. There'll be 2 different echoing programs. And the more sophisticated one will deal with kind of these bad tokens as well. I want to show you one last thing before we finish. And so I mentioned that Java doesn't handle files well. I said C++ grew up in the 80s when files were king, and that's why it does files particularly well. Java grew up in the 90s. And what was replacing files in the 90s? Normally I ask students, and the answer is the internet. That was what was really becoming big in the 90s. And it turns out that that Java I mean, even though a lot of these things are complicated, we're struggling a little bit with this, you know, the checked exception and so forth. It turns out that Java handles network files, network information, much in a very easy way. So, I mean, I've been saying bad things about Java. I wanted to show you at least one good thing about Java. So, suppose you were interested in our homepage, you know, for the 142 class. And so I'm going to make a copy of this URL. So, and I'm going to come over here, and I'm going to say that I want a scanner that I'm going to call input, which is a new scanner, and I'm going to connect it to a different source of input, something on the network, something on the internet. And so I'm going to construct what's known as a URL object by giving it that text, you know, the URL for our class web page. And there is a little something extra you have to do, so there's a little bit more to it than just that. You have to do something called open stream. I have to give kind of an extra command here. But otherwise, we're doing something very similar to what we did with the file, where we just kind of connected the scanner to that source of input. And if I say input.nextLine, it goes over the net, and it shows you the first line of that input file. What's the next line? What's the next line? This file and all linked documents, et cetera. The next line, CSE 142, spring 2020, the next line, the next line. You can process things that you have a URL for. So if you know, this is going to be very powerful for you, that if you want to be able to access things on the web, it's going to be very easy to do. So I'll include another thing on the calendar for today, which is a complete program that does this kind of thing, in case any of you are interested in playing around with processing data that's stored on the web. Okay, we'll do more in Monday's lecture.